In this video, I will explain how deep neural networks can generate art. Computer-generated art is not new. You can think of many mathematical phenomena giving rise to nice pictures, such as fractals or strange attractors, or more generally, procedural content generation, small programs that generate pictures, such as air systems. But a few years ago, neural networks entered the game. Deep Dream, for instance, took an image, identified what was present in it, which features were present, for instance a dog, some grass, a house, and then the network increased those features exactly as we would increase the contrast of an image. The result is often a psychedelic image with eyes or dog heads everywhere. But those examples are just happy accidents, which happen to generate interesting results, but they are not really creative. They will always produce the same kind of output. Can we do better? Can we teach a neural network to be creative, to generate new, original pictures in a different style each time, a style that has not been used yet, neither by humans nor by computers? Can a computer create art? Before we start, we need to define what we mean by art or beauty. It's a tricky question on which philosophers have pondered for centuries. They have provided several answers. Here are three of them. None of them is entirely satisfactory, but one will prove useful. First, something is beautiful to me if I find it beautiful, whatever my reasons. That definition is too subjective, and since my beauty is unrelated to your beauty, it is not really usable. The second definition is recursive. Art is what is recognized as such by the art community. But this art community is defined as the institutions regrouping most artists. That definition is circular. The last definition is historical. We already know which works were works of art in the past, those that were recognized as such in their time. We can then define works of art in the present as works that are similar to or build upon those past works of art. This definition is contingent. If history had unfolded in a different way, our notion of art would be completely different. But it will be useful. Since deep learning is data-hungry, the last definition seems the best to teach computers to be creative. We will ask our neural network to fulfill two goals. First, the images it generates should be recognizable as art. They should be sufficiently close to existing works of art. Second, they should be new, innovative, they should be different from existing works of art. They should be artistic, but not from any known style. The data used by the paper comes from WikiArt. They took 100,000 paintings with known styles. There are two main types of neural nets used to generate data: generative adversarial networks, or GANs, and variational autoencoders, or VAEs. The paper uses a GAN, which is the simpler of the two models. If you are not familiar with GANs, it's not one network, but two, a generator and a discriminator. The generator is given some noise as input and transforms that noise into an image. The discriminator is given an image as input and has to tell if it's a real image, a real work of art from the past, or if it was produced by the generator. To continue with the art analogy, the generator creates forgeries and the discriminator tries to detect them. They compete with one another. That's why it's called an adversarial neural network. That was a standard GAN. The creative adversarial network is a bit different. It has two discriminators. The first one is the usual one. It tries to distinguish actual art from computer forgeries. The second one tries to recognize the style of its input. The output of that second discriminator is a probability distribution on the possible styles. For instance, it could say, this picture is 80% classical, 90% romantic, and 1% fake. The loss function for the generator is also slightly different. The generator tries to fool the first discriminator, as usual, but it tries to confuse the second rather than to fool it. It does not want an incorrect prediction for the style, but uncertainty. It wants the second generator to output a uniform probability distribution on all styles. This can be achieved by maximizing the entropy of that distribution. That's all. Here are some of the images produced by that network.